Dear students, today we will study percentage composition. As we have started with a mole concept, now we will study percentage composition. What is percentage composition? Let us understand this thing one by one. Suppose you have been given a substance whose formula you are not aware of it. Okay. So what will you do? Information regarding the percentage of a particular element present in compound is very important. The first question comes in my mind is that what is formula? If an unknown substance to given to me, what may be its constituents? Constituents નો મતલબ શું? તો કે કાર્બન હશે, હાઇડ્રોજન હશે, ઓક્સિજન હશે. What element may be present over there? So, and what will be the ratio? What will be their ratio? These are the questions that comes in my mind. So what exactly happened? This concept, percentage composition, help us to even check the purity of a known component as well. Okay, in industry, if you prepare some compound, let's say एक टेबलेट बनाए જેને કહે છે આપણે PCM, actually it is called a paracetamol. ઓકે, હવે જે PCM બનાવ્યું છે પેરાસિટામોલ, ઇટ્સ અ ટેબ્લેટ. હવે આ ટેબ્લેટમાં કોમ્પોઝિશન કાર્બનનું, હાઇડ્રોજનનું, ઓક્સિજનનું કેટલું છે, એક્ઝેક્ટલી પ્યોરિટી કેટલી છે, that also we can understand from the percentage composition. So let's start how to calculate the percentage composition. Very simple to understand this concept. Okay, we will start up with a very small and very nice compound H2O. We have to find out percentage of hydrogen and a percentage of oxygen in this compound. So what will I do? To find out percentage of hydrogen, I will make sure how many hydrogen atoms are there. First I will write down that 2. Okay. So what is atomic mass of hydrogen? We are taking it as a 1. Okay, I am not taking it as a 1.008. Okay, I am just taking it as a 1. Then I need to find it out one concept that we have studied. It's a molecular mass. So molecular mass of water is what? So okay, already we studied how to find out hydrogen 1, oxygen 16. So 2 plus 16 is equals to 18. So guys, this is what I understand from this part. It means now it has to be divided by 18 and it is percentage, so it has to be multiplied by 100. So what is that? 2 upon 18 divided by 100. So let us have a calculator and find it out what is the answer. Okay, so 2 divided by 18 is equals to dash into 100. So your answer is 11.11. 11.11 percentage. So this is the percentage of hydrogen in a water. Now what about the oxygen? Okay, there is another way to find it out. Oxygen 100 માંથી minus કર દો સર તો આન્સર આવી જાય ને આપણને. Yes, we can find it out in this way also. But suppose you have more than 2 elements, then what will you do? So in this case, same thing, percentage of oxygen. So how many oxygen do I have? I have only 1 oxygen. What is atomic mass of oxygen? 16. What is atomic mass of hydrogen? It is 18 into 100. It means, okay, let us see this one. Okay, what happened? Okay, 16 divided by 100. Sorry, 16 divided by 18 into 100. What I get it? I get it 88.88. 88.88. Continue. So I am writing 88.9. Okay. So if I get this 100 minus 11.1, I will get 88.9 as a percentage. So students, this is the way we can find it out, the percentage of any compound. Okay. So any compound's percentage, this is called a percentage composition, where the composition has this percentage. So how can I write down this equation in a general form? So mass percent of an element is equals to mass of element in the compound, divided by molar mass of compound. into 100, or you can write down that number of atoms in compound into atomic mass of element divided by, it is going wrong way, something I have to do, divided by molar mass. So this formula we can utilize and find it out that what is a percentage composition of the compound. Let's see one example. My one of the favorite example, Na2CO3. Now this is the compound given to you and they ask find the percentage of each element. So let's start with the percentage of sodium. Percentage of sodium. So what is percentage of sodium? So percentage of sodium means how many atoms do I have of sodium? So okay, number of atoms of sodium are 2. Its atomic mass is 23. I need a molar mass. What is molar mass? So let's find it out. The molar mass of Na2CO3. It's 2 times nitrosodium, plus carbon 1 time plus 3 times oxygen. So 2 into 23 plus 12 plus 3 into 16. So 23 2s are 46 plus 12 plus 48. Okay, so 8 plus 2 10 plus 6 carried out 1. 6 plus 4 plus 1 5 plus 1 6 6 and 4 10. It's 106. So let's write down 106 into 100. Now what I do have? I have a calculator with me which I am going to utilize. Why? Because Gujarat government allows us to use a simple calculator. So 46 divided by 106 is equals to into 100. So my answer is 43.39. Okay, and that's it. This is what I am going to take. Now percentage of carbon. Let's say percentage of carbon. How many carbon atom? I have 1 carbon atom. What is atomic mass? It's 12. What is molecular mass of molar mass of sodium bicarbonate? Sodium carbonate. It is 106 into 100. So what I will do? Again, 12 divided by 106 is equals to multiply by 100. So my answer is 11.32 percentage. Sorry, I missed out percentage over here. This is what. Now the last one, the percentage of oxygen. How many oxygen do I have? 3. What is atomic mass of oxygen? 16 divided by 106. So what is this? This is 100. So what is it? Let's see. 16 3s are 48. 48 divided by 106 is equals to this. Multiply by 100 is equals to 45.28. 45.28. This is what the percentage. If you get this one, if you add all this, you will get round about 100 or 99.9. Why? Because some of the decimals we are not considering as we have to round up this all and then we can do it. But it's like this, you can make it out all the same way. So if you can just make it out, this will be 43.4, this will be 11.3, this will be 45.8, 45.3. So let's see whether it is going to get 100% or not. So if I will just make it out as a normal way, just rounding up to 3.43.4, this will be 11.3 only, and this will be 45.3. So let's add this 3 and let's make sure whether it is taking 100 or not, because any compound's total percentage of atoms will be 100. So 10 carried out 1, 5 and 1 6, 6 and 3, 9 and 1 10, 0 carried out 1, 4 and 4 8 and 2 10. So this is 100%. So this is how we can find it out, the percentage composition of the following compounds. So dear students, this is the way you have to make sure. And please, I have to tell you this, okay, whenever you are watching this video, please make a note of it. I am going to ask you to write down the note, and that note I am going to check it. Okay, so please dear students, make sure you write down notes very clearly. Okay, in your notebooks should be there, and a fair copy you should write down the notes. Okay, now let us see. I'm going to give you few examples for the revision purpose. Okay, or for your practice purpose. This homework. Please do this homework at home. Okay, what is your homework? So let us understand the homework over here. We need to find it out the percentage composition. Find the percentage composition of the element present in following compound. Okay, so I'm going to give you few examples. Please make sure that you do this and show it to me. Okay, number one, I'm going to write C2H5OH. Then number two, C12H22O11. Number three, NaOH. Number four, H2SO4. Number five, C2H2O4. Number six, CH3CHO. I want you to use your brain. 7, K2SO4. Number 8, KMNO4. These are the 8 questions which you have to solve it. Okay. Now let's see the another concept. Now here what we have studied about mass percentage. Okay, percentage composition. How can we find it out percentage composition? Now if I want to find it out, percentage of the element is given to you and you have to find it out molecular formula and empirical formula. So now we will study very nice concept, very easy concept, that to determine molecular formula and empirical formula. Okay, here we have to follow very nice steps over there. Now before we start this, let us understand what is molecular formula and what is empirical formula. Many times a question has been asked, okay, give the difference between empirical formula and molecular formula. Now I'm going to explain you with the help of an example over here. I have a molecule. Okay, I have a molecule. Wait a minute. Is C6H12O6. Okay. Now let us see what is the composition of this 6, 12, 6. Now if I will cut off this, I will get 3, sorry, 6 ones are 6. So 6, 1, 2 and 1. So guys, what I got it over here, you can see very clearly carbon has 6, 12 hydrogen and 6 oxygen. I get a simplest form, and when I write down this simplest form, CH2O. Now I have, this is my exact formula. This is called a molecular formula. A molecular formula. And this is my empirical formula. What is this empirical formula? It is empirical formula. Okay. What is this empirical formula? So it is, what is it? It's a simplest whole number ratio of various atom. It's a simplest whole number ratio. Dear students, okay, it's a simplest whole number ratio of various atom. You can see there are 3 atoms, okay, in this compound, of various atoms present in a compound. So present in compound, this is what we have to understand, guys. Okay, this is what CH2O. This is empirical formula. This is molecular formula. Now, how can I get it? This by if somebody has given me only mass percentage, then mass percent of a various element is given to me, present in compound, is its formula can be determined. Empirical formula can be determined, and then further with the help of molar mass we can find it out its molecular formula. So let us understand this. How can I do this? I'm going to take an example given in our textbook. It is given that problem number 1.2 given in our textbook on the page number of the textbook is 19. Okay, so guys, let's find it out how to solve or how to find it out or calculate empirical formula and molecular formula with the help of an example given in our textbook. Okay, so in the textbook it is given carbon has a percentage of 24.27, hydrogen has a percentage of 4.07, and chlorine has a percentage of 71.65. So to find it out, empirical formula, step 1, we have calculation of empirical formula. For this, I need to form a table. The first column we will write element, second column we will write percentage composition, third table we will write atomic mass, fourth table we will write mole of atoms, fifth table we will write mole ratio, and the sixth one column will write simplest ratio. Let's start with this way. I have carbon. So what is the element? Carbon has 22.27%, hydrogen 4.07%, and chlorine 71.65%. What is atomic mass of carbon? Atomic mass of carbon is 12, hydrogen is 1, and chlorine is 35.5. So moles, how can I find out moles? So second column is divided by third column. It means that 24.27 divided by 12, 4.07 divided by 1, and 35.5 divided by, sorry, it's 71.65 divided by 71.65 divided by 35.5. Okay, so if I will find it out, what will be the answer of this? this will be 2.02, this will be 4.07, and the last one is 2.02. So in this mole ratio, what you have to do, whatever the answer comes, you have to see which one is the lowest one, which one is the smallest one. The 2.20 is smallest, so divide every ratio moles by this mole, the lowest mole. So this one will be the answer, 2.02 divided by 2.02. So guys, what will be the simplest ratio? If I cut this one, I will get 1. 2.02, it will almost 2, and this is 1. So my dear students, therefore these are carbon is 1, hydrogen is 2, and chlorine is 1. So this is the way your empirical formula of this compound is what? So I can write down with here. So you can write down, therefore empirical formula is equals to carbon is to hydrogen is to Cl is equals to 1 is to 2 is to 1, એટલે is equals to CH2Cl. This is the empirical formula. So the step 1 is finished. Now let's go for the step number 2. What is the step number 2? Step number 2 is calculation of molecular formula. So step number 2, what is step number 2? Step number 2, calculation of molecular formula. How can I find out molecular formula? So let's find out first empirical formula mass. First we will find it out, empirical formula